Right, let's have a look here. So we've got y equals e to the 2x plus 3 all over x. Now, what I can see here is that we have got a function of x divided by a separate function of x. So this we're going to call u, and this we are going to call v. So u equals e to the 2x plus 3. U dash is going to equal 2e to the 2x plus 3. V is equal to x. V dash is going to equal 1. So now if we differentiate this, we should remember it's vu dash minus uv dash all over v squared. So I'm going to have x times by 2e to the 2x plus 3 minus e to the 2x plus 3 all about that times by 1 all over v squared, which is x squared. And so we could have said, well, actually, I'm just going to simplify this a second. When I multiply this, I'm going to get 2x e to the 2x plus 3 minus e to the 2x plus 3 all over x squared. Now, there's e to the 2x plus 3 common out of both of those terms, so I get 2x minus 1 all over x squared. That's my dy by dx. You might have given me an unsimplified version, that's absolutely fine, but it should have been over x squared. Now, I think about stationary points. At a stationary point, dy by dx equals 0. And I said to you last time that only the numerator ever is going to equal 0 when you make a fraction equal to 0. So at that point, we should have said e to the 2x plus 3 times by 2x minus 1 equals 0. So I've got essentially the first bracket equals 0, or 2x minus 1 equals 0. Why isn't x to the power of minus 1? It's always of the form u over v. U's at the top, v's at the bottom. And we're not bringing the x to the top here. We could bring x to the top and then do the product rule. We get the same answer. It might not look the same, but it will be the same answer. Yeah, that's fine. Now, ultimately, you should have got this equals 0 in your numerator. Now, e to the 2x plus 3, if we think about e to the 2x plus 3, it's a function of e to the x graph. Does that ever equal y equals 0? No, it doesn't. This one's got no solutions. Okay, because it'll have an asymptote of y equals 3, because this is a function of e which has not moved up or down, and therefore it does not cross the y, does not have a y value of 0. So the only other thing to do is to say 2x minus 1 equals 0, x equals a half from there. And that is the only point where we have a stationary point on there. It doesn't say find the coordinates, so I've just worked out the x coordinate. Is everyone happy with that? What do we have? We've got y equals, oops. y equals e to the 2x over x minus 2 squared. Again, this is u, and this we are going to call v. So u equals e to the 2x, v equals x minus 2 all squared. U dash is going to be 2e to the 2x, v dash is going to be 2x minus 2 to the power of 1 and times by 1, which is simply 2x minus 2. Now, thinking about it objectively, would it be a good point to expand the brackets out for v dash when trying to look at the answer? Is it sensible to expand the bracket for v dash when we try to look at the answer? No, it wouldn't, because that then won't help me cancel out. Okay, so just bear that in mind. If something is cancelled out, because I'm expecting x minus 2 to the power of 4 when I do v squared in my denominator. But this is 3, so something is cancelled out of all the terms, and that's why it's going to become more difficult to spot that if we expand this bracket out. So let's see where we get to. So dy by dx, vu dash, so x minus 2 squared times by 2e to the 2x minus uv dash, e to the 2x times by 2x minus 2 all over x minus 2 squared, because that whole thing inside the square bracket was v. Now if I factorize out the common terms of the numerator, every single term has a 2, so I'm going to take a 2 out. Every single term has e to the 2x, I'm going to take that out. Every single term has x minus 2 to the power of 1. So if I take that out, what do I get? I've got x minus 2 here, minus 1, all over x minus 2 to the power of 4. Are you happy with that? Does that whole bit of working out make sense here? Sort of factorized it in one go, didn't do the long process of cancelling terms down. Any questions, just let me know if you're unsure about any single term on there. But here, I can see that this can cross out with this to leave me with the 3. So I've got 2e to the 2x, x minus 3, all over x minus 2 cubed. And that looks very much like the format that we want it to be in. So a is the coefficient of e to the 2x, so I'm saying a equals 2. B is the coefficient of x, which is 1. And c equals 3. Are you happy with that? How does the x minus, oh, I've written that wrong. It should be x minus 2. Thank you for spotting that. Because if I take out 2e to the 2 minus x, both of these terms, again, I should really have done the process. So 2 and 2 is common. I've taken that. X minus 2 squared and x minus 2 to the power of 1. I've taken x minus 2 to the power of 1. And obviously then we also have e to the 2x, e to the 2x. That's why these three terms are the highest common factor. I just wrote that as x minus 1 in haste, rushing. Okay, are you happy with that? So let's have a look. So we've been asked to work out the equation of the tangent at the point where x equals 1. Now we worked out dy by dx. So we can say gradient of tangent, part B, gradient of tangent, and literally I would write that in the exam just so that I'm clear, is 2e to the 2 times by 1 minus 3 all over 1 minus 2 cubed. And so what do I get here? 2e to the 2 times by minus 2 over minus 1. So I am getting 4e squared here. So that's the gradient of my tangent. I know my x coordinate is 1, but I don't know what the y passes through, but I've got a y coordinate given to me there. So I can work out y equals e to the 2 times by 1 over 1 minus 2 squared, which is e to the 2 over 1, which is e squared. So now I've got everything I need. I've got m equals 4e squared. I've got x coordinate, I've got y coordinate. And now all I need to do is do y minus e2 equals 4e squared x minus 1. And I can leave it like that. I don't need to do any more working out. I don't need to make y the subject because it hasn't asked me to do that. When we think about y equals tan x, well, obviously we know that y equals tan x can be written as sine x over cos x. And now we've got two functions of x, separate functions, and they're being divided, so therefore we can use the quotient rule to do this. So u equals sine x, so u dash is going to equal cos x, v equals cos x, and v dash equals minus sine x. Once I have that, we need to use the quotient rule. So let's do that. Dy by dx equals v times by u dash. It has to be in that order. Cos x times by cos x minus sine x times by, in fact, v dash is minus sine x, so sine x times by minus sine x all over v squared, which is cos squared x. Now the numerator is going to become cos squared x, minus times a minus is plus, so we get cos squared x plus sine squared x all over cos squared x. Well, what can we do here? Well, we should recognize that the numerator can be written as 1, because we've seen cos squared x plus sine squared x. We've got 1 over cos squared x, which 1 over cos is sec, so 1 over cos squared is sec squared x. Okay, does that make sense? Is everyone happy with that? Please let me know if there's any bits that are causing a problem. Yeah, so are you happy with cos squared x plus sine squared x? That sums to 1, and then the new denominator is cos squared x. Now 1 over cos x is sec x from trig, because we've looked at reciprocal trig. And so 1 over cos squared is going to become sec squared. Right, how is minus, right? It's not, it's times, isn't it? That's a good question. I've not laid it out very nicely. So dy by dx for the product quotient rule is vu dash minus u times by v dash. This is a times, this dot represents multiplication. So when I do negative times a negative, that becomes a plus. Are you happy with that? Because in here, there is a multiplication, and this was u and this is v dash. So I'm actually multiplying them. Okay. So I get 1 over cos squared. 1 over cos is sec x, so 1 over cos squared is the same as saying sec squared x. If I had 1 over cos cubed, it would be sec cubed. Are you happy with that? Okay, perfect. So now we are happy with that. Is that if y equals tan x, dy by dx equals sec squared x. And we don't need to prove it from first principles each time unless it says show the proof of differentiating tan x or something like that. We can use this result. Now, based on what you have learned, I want you to differentiate tan 2x plus 3, please. Have a go at that and let me know how you get on. So, again, we're starting something new. It might look a bit daunting, but really I've got something here, so we can use the chain rule. Let u equal to 2x plus 3, so we get y equals tan u. dy over du equals sec squared u. Du by dx equals 2. And so dy by dx using the chain rule is going to become dy by du times by du by dx. And so we get sec squared u times by 2, which is better written as 2 sec squared 2x plus 3. Okay, is everyone happy with that? Any questions there? If y equals tan f of x, dy by dx equals f dash of x sec squared f of x. Okay, that is how we differentiate tan f of x. And that makes sense in the example above. If we differentiate 2x plus 3, we get 2 sec squared 2x plus 3. That's it, done. Don't need to stress about that. Right. So we've looked at the differentiation of tan x. Next thing that we are going to do is I want you to have a go at differentiating cosec x, please. Have a go at differentiating cosec x and let me know your answer as soon as you have it. Right, let's have a look. So, firstly, this is not in a helpful format. Minus cos x over sine squared x is the right answer. So that's fine. First, what we need to do is write it as 1 over sine x. and say this is u and this is v. So I can say u equals 1, u dash will be 0, v equals sine x, and v dash equals cos x. Now at this stage, we can use the quotient rule. dy over dx equals vu dash sine x times by 0 minus u, which is 1 times by cos x, all over v squared, which is sine squared x. Are we happy with that? Does that make sense up to there? So just check you're working out up to that. Now, this obviously anything times by 0 is going to disappear. I'm left with minus cos x over sine squared x, which I can write as minus cos x over sine x times by 1 over sine x. So I could have got minus cot x cosec x. Okay. Or we could have said is minus cosec x cot x. Right, okay, so what we have realized is that if y equals cosec x, dy by dx equals minus cosec x cot x. Okay, so now if we know that, can you please differentiate y equals cosec 5x squared minus 3x? Have a go at differentiating that and let me know how you get on, please. Send me your answers if you get there before me. So my first step here, I've got a funny bracket, so I'm going to let u equal the funny bracket. Again, if you're ever unsure, just start off with the chain rule and work it out properly. I can work out du by dx, that is 10x minus 3. Y becomes cosec u, so dy by du is going to become minus cosec u cot u. And so my final step, well, actually second last, so I'm going to have minus cosec u cot u times by 10x minus 3 due to my chain rule, which would have been dy over du times by du by dx. And so I can write this as minus 10x minus 3. Cosec u is going to become cosec 5x squared minus 3x cot 5x squared minus 3x. Or if you multiply the minus inside this bracket, that's also absolutely fine. Okay, can you let me know how you got on with that?